Well, okay, now matrix, this is my favorite, the inverse of the exponential graph. Okay, if you remember, an exponential graph would be 2 with an exponent x. Let's sketch these graphs. I'm really excited about this. Let's sketch this graph f and see what it looks like and see whether its inverse would be a function. Okay, so let's pick some x values for this quickly and work out the y's. I'm going to choose -1, 0, and 1. Okay, so what would the y be? 2 to the negative 1, 2 to the 0, 2 to the 1, and this is of course a half, 1 and 2. So that's really exciting. So if we take this graph and we draw it, let's see what we're going to get. This is a really nice graph. I love the exponentials. Okay, have a look here. X and y. And we're going to go -1, 1, 0 there, and let's go up. We can go from, say, 1 and 2. So there's 2, 1, -1, and 1. Okay, and if we look at this, let's just put some values here as well. -1, -2. Now look at this. If x is going to be -1, the y value is in line with a half there. Okay, and then it's 0, 1 is there, and 1, 2 is here. So here is your exponential graph. No problem about that. That's the graph of f. That is definitely a function because a vertical line will only cut it ever once. Now, how do we get the inverse of this? Well, we've got these values here, and we've got these values here. Now, I'm going to make, instead of saying x, y, I'm going to make it y and x. Now, watch this. Now, let's see if we plot this. This is going to be the inverse here. Alright, so if x is a half, which is there, y must be -1. If x is 1, y is 0, and if x is 2, y is 1. Now look at this. This is actually an interesting graph. It goes like this, comes up, and goes across like that. That's the inverse of the exponential. This is x is equal to 2 to the y. This one is y equals 2 to the x. And if you plot your little line y equals x, look at this. Definitely a clear reflection about the line y equals x. So look at this. This is, and look, also notice that the inverse is also a function because no matter where you go, a vertical line will only cut once. So the inverse of an exponential is also a function. Okay, but I've got a bit of a problem here because if you take the equation, watch this here. So we had y equals 2 to the x, and the graph looks something like this. So it looked like that. Great. Then we had our little line y equals x. The inverse looks like that. This cuts at 1, 0. This is at 0, 1. Interchange the x and y. But the problem is when you interchange this, how do we solve for y in a situation like this? Now, what we need is the concept of logarithms. Now, how it works, I'm going to show you before I even look at this. Let's take a situation where if I said to you 8 is equal to 2 cubed. Okay, 2 cubed. We know that 3 is the exponent and 2 is the base. So there's the base there. And this is the exponent, okay, which we already know. But now I'm going to change this. I'm going to redefine this. And I'm going to say something like this. I'm going to call the exponent something different. Okay, so what I'm going to say is the exponent is 3 and the base is 2. We can say that the logarithm to base 8. So what I'll do is I can say that the exponent 3 is the log. Now notice the symbol log of 8 to base 2 is equal to 3. So I'm giving the exponent another name. I'm saying the exponent is the logarithm, or we call it log, of 8, and the base gets written here slightly underneath. Okay, it's called log 8 to base 2. Okay, so what they're saying is if you've got really a number, whatever that number is, and it equals to the base raised to an exponent, okay, then your exponent, another way of defining the exponent is to say the log of that number, okay, the log of the number to that base there. Okay, so looking at this definition, we can say, for example, if I said to you 9 is 3 squared, well, the log of 9 to base 3 is 2. The 2, the exponent, is called the log of 9 to base 2. So if you've got here, for example, x is equal to 2 to the y, which we had previously, look at that there, x is 2 to the y, we can write this in a different form by saying the exponent y is the log of x to base 2, and that's y. And the word log comes from logarithm, okay, and it's another way of writing it. So in other words, if fx is going to be equal to 2 to the x, the inverse of this graph would be what we call a log graph, which is the log of x to base 2. So it looks like this. There's your 2 to the x, and your log graph looks like that. Okay, interestingly, the x is always positive for this one. Okay, so there we go. So that's sketching the graph of the inverse of an exponential. Have a look at another one. So I said to you, let's make a gx now for something different, is equal to a half to the exponent x. So that's y is a half x to the x. Okay, let's pick some values and sketch this graph. -1, 0, and 1. So what would the y values be here? Half to the -1, a half to the 0, and a half to the 1. So this comes to half to the -1. You can work it out as 2, 1, and a half. Okay, so how does the inverse work? Well, the inverse, we simply swap the y and x around. Okay, we'll keep those values as is, but now the inverse is going to just swap those two around. So if we draw this graph, okay, let's have a look at that. If we draw the graph of g, okay, there's -1, 1, 1, 2, -1, -2. So let's have a look here. If we draw this graph, the g would be -1, 2, so it'd be -1, 2, 0, 1, and 1, a half. Okay, there's a half there. Let's just check that quickly. -1, 2, 0, 1, and 1 and a half. Now, if you interchange that, let's have a look at this graph. X is 2, y is -1. Okay, this graph, of course, goes like this. Let's bring it down. There we go. Okay, that's the graph of g. Now, the inverse would be, okay, if you go x is 2 and 2 minus 1, which would be there, then you've got x is 0, y is 1, and if x is a half, your little value there is going to be 1. Okay, so if we draw this graph looks like this. It's also a function. It's the inverse of the g. Look at that. And if that is 0, 1, this is 1, 0. It's the inverse. And you can draw that on there. Do you see? What a pleasure. And this is the graph of the inverse there. Now, and you'll notice that they're all reflections about each other, about the line y equals x there. Okay, so that's quite important. This would be -1, 2 here at this point, and this would be 2, -1. Notice they completely swap around. And if you take the equation of this graph, look at this. If y is equal to a half to the x, that's g, then the log, what we can do is we can interchange those. We can interchange the x and y, so let's do that. X is equal to a half to the exponent y. Introduce the log notation. Log x to base a half is equal to 1. That is your inverse. It's the log graph. So what's quite interesting with these guys, if you think about it, if you've got an exponential graph like this, there it goes, y equals 2 to the x, its inverse would be this graph, which would be y equals log x to base 2. And if the graph is going down, it's almost, they call this a decreasing graph like this. Y is equal to a half x, half to the x. The inverse does this, and you look at this. This is the line of symmetry here, the reflected line, y equals x. This would be y equals log of x to base a half. You see that there? So these are wonderful shapes. These are called the logarithmic graphs. They're the inverses of the exponentials, and they are very useful. We develop a whole lot of theory out of this when we deal with that. Okay.